This is the sixth and final word work problem and has a new wrinkle to it. If we read the problem, the large tank has two input pipes, A and B, and one drain, D. Pipe A can fill the tank by itself in 2 hours. Let's get my color. Pipe A is going to fill it in 2 hours. Pipe B is going to fill it by itself in 3 hours. Now we have a different situation here because the drain is going to empty a tank. So the water is going to come out that way, and that would do it in 6 hours. So if we go back and figure out our box of data here, A can do the job in 2 hours, B can do the job by itself in 3 hours, and D, the drain, can empty the tank, a full tank, in 6 hours. So therefore, following our normal policy, the rate is 1 over the time it takes to do one job. So A is 1 over 2, B is 1 over 3, and the drain, D, is 1 over 6. Now they're all working, but we have a situation here, we're looking at who's doing the correct job, and the job is to fill the tank. Therefore, A and B are doing the correct job, whereas the drain, D, is working against the job. Now, they're all working the same amount of time, regardless what kind of work they're doing. And we don't know their time, so that would be our variable. So A is going to work for time T, B is going to work for time T, and drain D is going to work for time T. Multiplying rate times time, as we normally do, to find the work. The work done by pipe A is T over 2. The work done by pipe B is T over 3. And the work done by drain D is T over 6. Setting up our generic equation, we know that the work done by A plus the work done by B, because they're doing the correct job of filling the tank, minus the work done by the drain, because the drain is working against the assigned job, which is to fill the tank, equals 1. Now we could end up with a negative number here, which would tell us that the drain empties so quickly that the pipes wouldn't overcome that, but we'll see what we get when we do our answer here. So the work for A is T over 2. The work for B is T over 3. The work for the drain, which is contrary to what we want, is T over 6. And that's going to equal, hopefully, 1 full tank. For 2, 3, and 6, my least common denominator is going to be 6. So I'm going to multiply everything by 6. Again, I have a distribution over here. When I multiply 6 times T over 2, the 2 cancels, and I'm left with 3T. When a 6 times T over 3, the 3 cancels, I'm left with 2T. And when I multiply the last one, the 6's cancel, so I'm left with minus 1T. Again, it's working against the job, therefore it's the minus. That's going to equal 1 times 6, which is 6. So I have 5T minus 1T, so I get 4T equals 6. Divide by 4, and I get T equals 3/2, or 1 1/2. So we take 1 1/2 hours to fill the tank if the drain is left open while the pipes are running.